Okay, let's start. So first, I want to go over what we did last time. So let's see. Last time we did okay. So here is the coronary, right? The tangent, right? If we have a tangent to a circle, then the angle of OBA must be 90 degrees. So it's a perpendicular with the radians. And now the coronary. What's the first coronary? The first coronary just say that the angle of, so if AZ is a tangent line, then the angle of BAZ, so that angle, let's see, so this angle, right? This angle is the same as half of the arc of AB. Okay, and then in other words, it's just the same as this angle here, right? So that the two angles are the same. Okay, how do we prove this? Let's take a quick look. Oh, we use the right angle, right? So the first one is a 90 degree minus angle one, and angle one corresponds to half of the BC, right? And then use half of the circle minus that. Okay, very good. And then the other one, this is the angle outside, right? So one side is a tangent to the circle. So how could I get angle of P? Angle P is half of the measure of the arc AB and minus the measure of the arc of the AC. So AB minus AC, and take the difference, divide by 2, and that is this. And how do I prove this? The proof actually is very straightforward. You just use angle P is equal to angle 1 minus angle 2, right? What's angle 1? Where angle 1 is just half of the AB, and angle 2, according to what we did earlier, is just half of AC, right? Okay, so we get that. And what's the next one? The next one is to prove that, okay, if I have a point outside the circle, then I can draw two tangent lines, right? I can have a PA and PB. Then I want to show that PA and PB are congruent. Okay, why? I think you have two ways to prove it. The first way is that you can, let's say, so you have, first of all, you have the 90 degree, 90 degree, right? And then you use the first theory, right? So that's the first theory today, right? Today means that the other day here. And then we have the tangent line, right? So and then we have we can have the congruent triangle, right? The two triangles are congruent. Why they are congruent? You have two sides, you have the right triangle, right? So the reason is the HL. Right, so that's the for this one, and I write the proof one. You can have the proof two. Proof two is actually you can use the Pythagoras theorem, right? So both are right triangles. If you have the two sides to be the same, then the other one should be the same as well. Okay, that's actually here, the Pythagoras theorem, right? You can have this, right? The R is 5, the OP is 13, then what is that? PA? PA is 12, okay? And then we talk about the cyclic quadrilateral. And that's a very nice theorem. So if I have cyclic quadrilateral, then the sum of the two opposite angles should be 180 degree, right? And that's one way you prove this, and then you prove the opposite way, okay? And the last problem is very tricky. Just take a quick look for one more minute. Suppose AB is a tangent to the inside the circle, right? The length of the AB is 10, right? I want to find the area of the washer. So the washer just means the area between the two circles, right? So by the definition, it's a pi r square minus a pi little r square. So it's a pi of the capital R square minus the smaller r square. But the tricky thing is that the capital R square minus small r square is just AC square because of the right triangle. Right, so that makes things much easier. So the AC is equal to 5, and again you have to prove that. So even if it looks like it's half, like C is half in the midpoint, but you still have to prove that by using congruent triangles. Okay, so that's from last time. And any question? Are there any question? Okay. And today, let's move to today. So today I'm going to first give you, let's see, just a couple of problems. Let's say, so let's try some. Uh, okay, so let's say, suppose I have a circle here, right? And then let's assume we have this way and maybe that way here. So this is A, B, C, D, and E here, right? So given the following, given that the arc of AB is 40 degrees and the BC, the arc of BC is 103 degrees and CD is 83 degrees. Okay, and I want to find the angle of the AED. Okay, give everyone a minute. Let's try that. Okay, so let's go the previous one. Any answer? Uh, where AED, if you look at the picture here, AED obviously is much bigger, right? It's bigger than 90 degrees. So how could someone tell me it's a 48, 47 degrees? Okay, think of that. Well, let's see. So first of all, I want, okay, let me try to figure out this one. Okay, let me try to figure out this. How about this one? Okay, so I'm gonna figure out the AEB. Okay, so let's see. The angle of the AEB, or according to a theorem we learned earlier, is just half of the AB and plus the CD. Does it make sense? Right? Okay. Oh, I think someone's made a mistake here. E is not necessarily to be the center. So E is not the center. E is not necessarily to be the center. E can be anything, any point. So you, all right. So AEB, the angle of AEB, just half of the sum of the AB plus the CD. Okay, and then we can get the half of what's the size, what's the AB, where AB is a 40 degree and CD is 83 degrees. So we can get the 1/2 times 123 degrees, right? So what is that? Well, this is 61.5 degrees. That's just a AEB. But now I can get my answer. Well, how could I get my answer? Well, you can just say I'm going to go from here, right? This is 180, right? Minus 61.5, right? That's what I want here. That's right. So this is 180 minus the supplementary angle. So that's equal to 100, 118.5. So that is my answer. Okay, that is my answer. Right. Everybody's okay? Right. Okay. Let's think of that. So how can we do that, right? Right. We get that. So that's that. We use the formula for the angle, which is inside the angle, inside the circle, right? So that's the theorem we did earlier. So don't forget theorems. So the theorems are very very tricky, right? Okay. Next problem. Let's see. We get this one here. So let's say angle Y is 58. So this guy is 58 degree, and this guy is 20 degrees, right? And then we have XZ is perpendicular with WX. Where is WX? WX is here. So that means this is 80 degree. Okay, this is 90 degree. Right, this is 90 degree. And then I'm looking for, so I want to find the following. I want to find the WOV. So what is the WOV? WOV. So that means I'm looking for this angle here. I'm looking for this angle. Okay. So give everyone a minute. How could I get that one? All right, so anyone get the answer? Okay, so I'm going to, let me just write that. So first of all, I can write this one equals, so if I have this one here, right, this angle, let me use the angle 1 here. Angle 1 and plus this angle W. All right, so angle 1 and angle W. So I only have angle 1 plus angle W. Right, this is a exterior angle theorem, right? It's angle 1 plus angle W. But what is angle 1? Where I can write angle 1 to be angle Y plus angle V. Okay, Y. So angle 1 here is the sum as angle Y and angle V, Y. It's again the same thing. It's a exterior angle theorem, right? Angle 1 is exterior. So it's the sum of the angle Y and angle V. Very good. So let's try that. And I know that angle Y is equal to 58 degrees. That's for here. And angle W is 20 degrees. But my question is, what is angle V? Can someone hear me? What is angle V? Is angle V the same as angle W? This is actually the same as angle W. Why? Why the two angles? So here's one angle, here's the other angle. Why the two angles are the same? Because they are inscribed angles of the same arc. They are both inscribed angles, right? And inscribed to which arc? It's XZ, right? So they have the same measure, right? That's what we did earlier, right? And therefore, so we can get the 58 degree plus 20 degree plus 20 degree, and that's equal to 98 degrees. Okay, everybody's good, right? So we just need some practice. Okay, we just need some practice. Anyway, so today I'm going to switch the topic a little bit. We have already learned the circle here, right? We have the perpendicular. We have the end tangent line, and tangent line is related to perpendicular, right? So I want to change the topic a little bit and then come back again, maybe next time or maybe after that. So today I want to do some geometric constructions by using ruler and a compass. Okay, so here is a topic for today. Because for when we have the geometrical construction, we need to do lots of circle, right? That's related to circle. So here today, so for geometric constructions, we only use two things. One is the ruler, and the other one is the compass. Okay. What is lunar? Well, lunar we know that we all know that the lunar, right? It's just has a finite length, and only one straight edge, one edge. Okay, and some people call it straight edge. Okay, and keep that in mind. When we use the lunar, we do not assume that there's a marking there. So no marking on it. No marking on it. Just a straight edge. Okay, it's just a straight edge. So some people call it a straight edge. So also it's called a straight edge. So a lunar, or I can get straight edge. Okay. Compass, where we know that we can use compass to draw circles. So these are the things we can do. Compass to draw circles, right? So basically, you can only use the two things. Okay, you can use ruler to connect the 2 points. Like you can make a straight edge, right? That's one thing. Or you can use a compass to draw a circle, right? and with any radians, with any center, right? Okay, so based on that, and then we can say, well, what kind of things can we draw, right? What kind of things can we draw? Well, we can draw actually lots of things, and there are something that we cannot draw, right? So let's say, first thing is that we're going to do the angle bisector. Can we draw angle bisector? Where what is called angle bisector? Angle bisector just means that so you have the suppose we have the angle here, right? And I want to get something between the angles so that they separate the angle into half and half, right? So that's a problem, right? I need an angle bisector. Okay, so how can we do this? I give everyone 30 seconds. Let's think of that. Let's think of that. Okay, so let me show you how to do this. First of all, I'm going to draw a circle, right? I'm going to draw a circle with the center at O. O is just the vertex of the angle. And you may ask me, well, what is the radius of that circle? Any radius, okay? So let's say, suppose I do this. Okay, let's see, something like that, right? I don't draw the entire thing because the only thing I want is that is the intersection part. So you get A here, you get a B here. Everyone is okay, right? I didn't draw the entire circle. So actually, most of the times, you don't need the entire circle, right? So when we say I draw a circle, it doesn't mean I draw the entire circle. I just draw a part of the circle, right? I just draw a arc here. All I want is the intersection point, right? So you got the intersection of A and B, right? That's your first step. And the next step is that you are going to draw circles with a center at A and B respectively, and with the same radius. Okay, the same radius means that the two centers, the two circles have the same radius. It does not have to be the radius of the previous one. Okay, so step two, we're going to draw circles of the same radius. Okay, with a center with centers at A and B respectively. Okay, so what does that mean? So that means you're going to use the A as a center, right? You're going to use A as a center, and then I draw a circle. So let's say, so I'm going to use A as a center. Let me use a different color because otherwise it's hard to see it. So A, I can do that one here, right? A has a center like that, right? So that's my circle here, right? With A at the center, and then I do the same thing with B at the center. So maybe something like here, right? Like that, right? And then, as you can see, that the two circles intersect. Of course, you don't make the radius too small, right? So relatively big, but not too big, right? So you have the two circles with the center of A and B, right? And they intersect at 2 points. But I just need a 1 point. So let's say I'm going to intersect here, right? Suppose this point is uh, is a C. Okay, intersect at the C here, right? And then what I'm going to do is that I'm going to connect the AC, actually make an extension. So step three is that just connect the OC, and the conclusion is that OC is your angle bisector. So your final answer will be, let's see, I'm going to just use a different color here, just go from here, maybe just use the this one, the green one. So that will be my angle bisector. Okay, my doesn't seem to be like that. All right, so that's the angle bisector. But how can you prove it? Okay, so everyone knows how to do that, right? So let's see. Uh, Let me show you. I think I Google the internet and there are many websites that show you how to do this. Okay, so let me share with one of this. So I'm gonna do let me do one thing with you. Okay, can you see my screen here? Everyone, can you see my screen here? Right. So it's an internet. It's a website from the internet. So let's see how can we do that. Can you see that? So first of all, can you see that I have a angle here, and I use my compass to draw a circle, but not the entire circle, just a arc, so that I can get the intersection of A and B, right? And after I get my A and B, so let's go back a little bit. You see that? So I get my intersection of A and B, right? And after I get my intersection, then I'm going to move my compass. All right, so going here, you see that? So here, this is the center here. That's my B point, right? And then you draw a circle. Again, it's just a part of a circle. So let's do this. All right, and then the other one, can you see that? So, and then that's the second circle here. And then I start to draw a third circle, start with the center at my A point here. And then you get the intersection point. That intersection point is my C point. Okay, and next one, I just need to connect the O with C. So let's do it. That's a straight edge, and then I'm done. So that is the angle bisector. All right. So can you want to let's take a look again. All right. Excellent. All right. So I'm gonna go back to my iPad. So the next question is where, let's see, we know how to angle bisector, the angle, but why? So how can you prove it? I think it should be very straightforward. How do you prove it? So let's prove it. Let's see. I'm going to prove this. Okay, by using the let's see the congruent triangle. So I'm going to let's see. I'm going to connect the I'm going to connect A and C. So let me connect. We use a different colors. So let's see. I'm going to do this one here. Connect the A with C here, and connect the B with C. All right. So I'm going to connect the AC and BC, right? And so I want to see the two triangles are congruent triangles. That's very easy, right? First of all, OA equals OB. Why? Because I draw that first circle, right? Cut A and B. So both O and OB are the radians of my first circle. Okay. And the second, I have the AC equals BC. Why? Because they are the radians of the second and the third circle. But both circles have the same radius. So keep that in mind. We got the same radians, right? We have the same radians. And finally, we still have a common angle, common side, OC. So that becomes the triangle of the OAC is congruent with the triangle of the OBC. And that says that the angle of the AOC is the same as the angle of the BOC. And then we are done. Right? So far, so good. So that's very easy. Okay, next one. So, any question? Excellent. Next one. So I'm going to do let's say, suppose I want to draw a perpendicular line. Okay. Next one. It's a perpendicular to a point, let's say that P on a line. Let me call that L. All right, on the 9, L here. So what does that mean here? So that means I have the following question. All right, my question here is this: I get I get my O my AB. So let's see. So this is my straight line here, the L, and I got a point here. I got a point P here, and I want to get what I want is that I want to get the perpendicular line. Okay, going through the P and perpendicular to the given line. All right. So that is what I'm looking for. So that's the line I'm looking for. Everyone knows that. I want that the perpendicular line. So how do I draw that perpendicular line? Keep that in mind. You do not have a right angle, right? You do not have the right angle. You don't. All you want is you have a straight edge, you have a compass, right? How can you do that? Okay, so let's think of that for a couple of seconds. Let's think of that. How we can do this. All right, so now I'm going to show you how to do this. Okay, again, we have a few steps, right? The first step, so I don't want to draw the whole thing. So actually, you can, I just want to show you how to do that because it's very time consuming if I write down the whole thing. So first of all, I want to draw a circle with the center at P, right? All right, so let's draw a circle. So let me try to draw a circle like that. Let's see. Not very nice. Okay, maybe somewhere here. Okay, let me go from here, here, maybe some here. Right. But anyway, so you don't have to draw the entire circle as I say that. So I just let me just draw part of that, half of a circle, semicircle. So all I want is that the intersection point. So I get the A here, I get the B here. Does it make sense? I get A here and I get a B here. And then I can do the following. So starting from A and B, right? Starting from A and B, and you go from A, right? You go from A, you draw a circle, and you go from B, you draw another circle, but with the same radius. So let's assume that. Let's try to do. I try to do. Maybe. I don't know. Let's see. So let's say something like that, right? I can get a circle in this way, right? So that's the circle center at A. And then I can get another circle, right? So let's see. Okay, I can get another circle, something like that one here, right? And then center at B here, right? So I can get the 2 points here. So one is a point C and the other one is a point D here. But I just need one of this. Okay, I just need one of this. So let me call that C here, right? And then finally, I just connect the connect the PC. So connect that one and it goes there, and that will be the perpendicular line. Okay, that will be the perpendicular line. So actually, if you compare this construction with the previous construction, they're actually the same. Okay, why they are the same? They are actually the same. Can you see that? Why they are the same? So the perpendicular line is just the same as the previous one when I draw the angle bisector. Because if the original angle turns out to be 180 degrees, what happened? So you see that. So let's see. If the angle of the AOB is 180 degrees, it just becomes the next picture. Can you see that? The previous picture was true for the general angle bisector. But if the angle is 180 degrees, that means the angle is a straight line. And if it's straight line, how do you have a half of the 180 degree? You have to 180 divided by 2, that's 90 degrees. So that's does it make sense? So you can see that it's exactly the same idea. Does it make sense? Right? And so it's the same thing. So basically, it's just the same as before. In the case that if the angle is 180 degrees, so we can get this. Okay, let me give everyone 1 minute. Right. Okay, next one. Okay, next one. Well, what happens if the P is not on the 9? Okay, the previous problem is that the P is on the 9, right? So let's see. Suppose I say I want a perpendicular to a point P, but this P is not okay. This P is not on a 9, not on the 9. Okay, not on the 9 of L. So what is my question? Well, my question is the following. Okay, so I got the straight line here. That's a L, right? And I get a point somewhere which is outside of the 9, which is out. It is not on the 9. And what I want is that I want to draw a perpendicular line going through P and perpendicular to the given line. So that is my question, right? I need to get such a line here. Does it make sense? So that's what I want. Okay, that's what I want. Okay, so how do you get this? Okay, so let's go back the picture. How can I get that? Again, the idea is quite similar to the previous construction. I want to give everyone 30 seconds. Let's think of that. So how do you make that? Right, the previous one, P is on the 9. Right, you can do this. And you can get a connection, you can get the intersection point of A and B. But what happens if P is not on the 9? Can you do the same thing, basically? Yeah, you can do the same thing. Can you see that? So there's no much difference between the two parts, right? P is on the 9 or P is not on the 9. You can always do the same thing. There's no big difference. Does it make sense? Right? So well, anyway, I want to give everyone a 1 minute. Let's think of that. Why there's no difference here. Let's think of that. Okay, so let's do it. So first of all, I'm going to draw a circle. So let's see, I'm going to draw a circle around that C here, right? All I want, again, you don't have to draw the entire circle. All I want is the intersection point. Here's A, and here is a B here, right? That's all I want, A and B. And now I just use the same trick. So let me just quickly work on that because it's just the same thing here. So I go from A here, I draw a circle. So going A here, draw a circle, right? Going from here, right? And then going from B, I can draw another circle, something like that, right? Again, the radius of the circle, not too big, not too small, right? And then you get a C here. So that's your point of C. And then you just connect the P with C, and then you are done here, right? It's the same proof. Okay, same idea, same proof. Okay, can you tell me why this is true here? Okay, let me show you the website, the animation, and so that you can have a clear understanding. Let's look at that again. Okay, give me a second. I'm going to do this way. Okay, so everyone see the picture here. So basically, let me go back here. I get a straight line here, and I want to draw. I'm going to go from a point and draw a line perpendicular to the given line. Let's see that. So that's a 9 here. That's the point. You see that? That's the point here. I go from a point and I draw a circle, right? You see that? So I don't have to draw the entire circle, but just the intersection points, right? So you got the intersection points A and B, right? And next one. You go from here, right? That's one circle. That's the second circle, and you get a C here. And then you're going to connect this, and that is it. Okay? Let's see again. Let's read again, right? So you go from here and here, right? Right, and going from this way, that's one, and then another circle, got an intersection point, and make the connection. Okay, so that is a way to draw a perpendicular line and to a point which is on the circle, on the line. And now, how about outside? Okay, let's see. Basically, a point not on the line. Okay, so let's see. I'm going to get from here, right? That's not on the line. Can you see that? Again, I need the 2 points here, right? The A and B, right? I have the 2 points here. And then after that, you see here, all right? Can you see that? All right, let's watch it again. One more time. Excellent. All right, so let's see. Let me go back to my iPad. And how to prove this? Well, to prove this, actually, very straightforward. I can just write down it quickly. There are 2 steps for uh, using congruent triangles. Okay, so let's see. Let's do this. So proof. All right, so I'm going to prove it. Okay, first of all, I can connect. So let's do the connection. All right, so I'm going to just connect the AP, connect the BP, right? And I connect the AC, and I connect the BC. All right. So basically, so first of all, we have the A, let's say AP is the BP, right? And then we have the AC is the BC, right? Why the first one here? The first one is just the first circle, right? That's the first circle, radius of first circle, radius of the first circle, right? And then it's the radius of the second and the third circles are the same, right? And then we have the PC and the PC, right? We can get the 2 triangles are congruent triangles. So we get the BPC, but that does not mean they haven't proved the perpendicular yet. I need one more step. Okay, I need one more. If that's the case, then that implies that. Okay, so let's see. And this implies that, let's say, angle 1 equals angle 2. Let me show you what's angle 1. Angle 1 is here. So that's my angle 1. And this is my angle 2, right? And now I use the angle 1, angle 2. I can do the following. So first, I can have the AP equals the BP. And secondly, let me call that H here, okay, the intersection point. So I get the PH equals the PH. That's the same common point. Now we are ready to go over the triangle of the APH with the BPH. Right. So I don't use it. First of all, I use the entire circle, entire triangle. But now it's not the entire triangle. It's just the 2 triangles above the 9. Okay, because I have the angle 1 equals the angle 2. And because of that, so this actually implies the following: the AH equals the BH. And furthermore, the angle of AHP equals the angle of the BHP. And that must be equal to 90 degrees. Why? Because the sum of them is equal to a straight angle and equal to 180, and therefore one of them must be 90 degrees. Okay, and we are done, right? So we not only we show that the two lines are perpendicular. So the conclusion is that the PC not only is perpendicular with AC, furthermore, actually PC is a perpendicular bisector of AB. So further, so actually PC is the perpendicular bisector of AB. So let me give everyone 1 minute. Okay, why is a perpendicular bisector? Just because we have this, right? So that means H is the midpoint of AB. And secondly, this is a perpendicular line. So PC is a perpendicular bisector of AB. And that's actually stronger than what we want. All right. Just give everyone 1 minute because the next one will be how to draw the perpendicular bisector. It's actually here already, right? That's just here already. So how to draw the midpoint, how to draw the perpendicular bisector. Okay, so give everyone 1 minute. It's exactly the same thing. Okay, so let me okay, so basically next one, we are just done already. So I want to find the midpoint, okay, and the perpendicular bisector of a 9 segment. Okay, why it's done already? It's just a previous picture, right? I give you that one here. AB is a 9 segment. All I want is that I want a perpendicular bisector. If I can get a perpendicular bisector, I can get the midpoint, right? So the question here is that suppose I give you a 9 segment, how to get a midpoint? How to get the perpendicular bisector, right? Can you see that? So let's see, how can we do this? Okay, I want to give everyone some time. Let's think of that. How can we get the perpendicular bisector, or how to get the midpoint? It's the same thing, basically. Okay, so let's just quickly do that. And where so first of all, I'm gonna draw a circle, right? I'm gonna draw a circle around A, right? So I'm gonna draw a circle centered at A, right? So that's one circle, right? Again, I don't have to draw the entire thing. And then the other one, I do the same thing. I can draw another circle with the same radius, right? Again, with the center B. So I get the two intersection point, right? One I call that C, the other one I call that D. And then as you can imagine, I just connect the B, C, and D, right? So connect the C and D, right? And then that is the perpendicular bisector. And the intersection point, that must be a midpoint. Okay, that must be the midpoint. All right, and then we are done for this one. Everybody's okay? Right, so Let me give everyone one more minute. Okay. So these are just warming up, right? These are just a warming up. So let me. So we have. Let's go back to where I just give everyone 1 minute. Okay. So I give you a 9 segment, right? How to get the midpoint and how to get the perpendicular bisector. Are there any questions? Any question? All right. So now, so these are the warming up. Now I'm gonna give you some hard problems. So since we're talking about the circle, right? Circle is the main topic for this course, for this semester. So the rest of the part will be related to circle. So I'm gonna do the following: how to construct the tangent line of a circle. Okay, how to construct the tangent line of a circle. So that's the next one. Let's see, um, construction of tangent line. Okay, construction of of a tangent lines to a circle. Okay, to a circle. So you have a circle here. How do you draw a tangent line to a circle? Okay, so first question in this direction, where suppose a point is given. I want to construct a tangent line through a point A. So given a point A on a circle, and what I want is that I want the following. I want a tangent line, actually the tangent line, because it has to be the one here. Okay, has to be. I want the tangent line. I want the tangent line going through the point of A. Okay, so let me draw the picture. So what I'm looking for is the following. So I have a circle. I'm not good at drawing. Right? So let's say I get a circle here and with a center. So each time when we have a circle, we are assuming that center is given. Okay, and assume that this is A, I get a point of A here, right? And this is O here. So I get a point on the circle, right? I get a point on the circle. What I want is that I want a tangent line going through the point of A. So in other words, I'm looking for that stuff here. So how could I get that one here? Everyone understand that? That's what I'm looking for. So just give everyone some time. Let's think of that. Okay, let's think of that. You can actually do it. All of the warming up technique was already introduced from the previous ideas. Okay, so let me just go over the previous ideas just in case you forget. Okay, first one, angle bisector. So if you give me an angle, I can always do the angle bisector, right? That's one thing. You know, it's just each of them just like a package, right? You know this package, right? So suppose I give an angle, you know how to draw the angle bisector. All right. Suppose next one. Suppose I give a straight line and with one point on the line. How to draw the perpendicular line going through the point P? And you know how to do this? right? And then what happens if the P is not on the line, is outside the line? I still want the perpendicular line to the given line, and that's how you can do this. Next one, for any given line sector, the line segment, how do you get the perpendicular bisector? How do you get the midpoint? Right. So these are the basic idea, right? Suppose we know that already. Okay, so now let's think of that one. All right, I get my point. I get a point the the circle. I want to draw a tangent at the exactly the point of A. Okay, how can we do this? All right. Yes, I get someone from the chat actually got the correct idea. Okay. So let me repeat the person is a banner. You are doing excellent. So I'm going to copy your comments and send to the send to everyone. Let's take a look. So here's a comment from one of you. Okay, it says that I'm going to connect the OA and make a perpendicular line that pass through A. That's excellent. Why does that work? Okay, think of that. So here's some suggestion, right? So I'm going to connect the oops, wait a second. So it says that I'm going to connect the OA, right? And then I get a line segment, or I get a straight line, right? You can have a straight line actually, because when you draw the perpendicular line, you need to make an extension. Anyway, so let's make an extension here. So I get a straight line here, right? And all I want is that I want to draw a perpendicular line through the point of A. Why? Because that's a theorem we did last time. So where's the theorem? I think it's somewhere here. That's the theorem. You see that? The first theorem is here. So if I have AB is a tangent line, AB the tangent line to the circle of O, if and only if OB is perpendicular with AB. So that means if I can draw the perpendicular line, right? How could I do that? If I can draw the perpendicular line, then that must be a tangent line. So perpendicular line is just a tangent line. Does it make sense? So that's the idea. Okay, so let's go back to here. And then we are done. Does it make sense? How to draw the perpendicular line? That's just a warming up exercise, right? So you go from here. So first, right? So let me draw that first. Connect OA. Second, you just draw A something, right? Just draw A something, AB, right? Draw AB perpendicular with OA. How? How to do that? Well, that's just a previous package, right? It's just like you have a bunch of packages, right? Whenever you need that, okay, I'm going to open this package. That's a tool, right? I can do this, right? So I skip the second type, the second step. The second step is actually from here, right? So that is you go from one point, right? You draw the perpendicular line with a given point, with a given line, right? Does it make sense? So what's the theorem behind that? The theorem behind that is just the tangent line, right? A line is a tangent to the circle if and only if the line is perpendicular to the radius passing through that given point, right? Okay. Does it make sense? Right. So I just say how to do that. We did that earlier. It's a previous previous problem, right? And why? Why again? This is a theorem, right? It's a theorem we covered 2 days ago, 2 weeks ago. It's a theorem covered 2 weeks ago. All right, and then we are done, right? So as long as they are perpendicular, so there must be a tangent line. Okay. Now next one. What happened? So that's my first question. All right, second question. Question number 2. Given a point where the previous question, if you look at that, read the question again. The point A was on the circle, right? But what happened if the point A was not on the circle? In other words, just outside the circle. It cannot be inside. If it's inside, you cannot draw the tangent line. So it has to be outside. So what happened if the point A is outside of the circle? Can I still, how do you draw? Well, certainly you can draw the tangent line, but how can you draw the tangent line, right? Okay, so let's see. Here's my second question. Let me write down my second question. So given a point A, which is outside of the circle, right? Outside of a circle, right? And then you are going to, I1 is tangent, tangent, tangent line going through A, right? In this case, actually, you can draw two tangent lines, right? But I just need one. So one of them will be good. So how could I do this? This is a little bit hard. So let's try that. Okay, so let me do this. So suppose I have a circle like that, right? And with a center O, and I got a point outside A here, right? So what you want is that you want the tangent line goes through the A, right? You can actually draw two of this, but they're the same. If you can draw one, you can draw the other one. So I just need one of them. So how can you draw the other one? Okay, I'll give everyone a minute. It's very tricky. This is very tricky. So again, you are going. We don't have much time left. I just give you the idea. Maybe we can do that next time. Let's say the idea was that where what is a tangent line? If you have a tangent line here, right? If you have a tangent line here, right? If you got a tangent line, right? And then that must be a right angle here, right? So basically, you're going to find a point P. So how to find a point P? Find a point P such that OP is perpendicular with AP. So how can you find such a point P, right? If you can find such a point P, then we are done. Okay, but how? Let's think of that. Okay. Uh, I'm going to give you a suggestion. Okay, so here's a suggestion. Where how could I get a point P with with that right angle? So sometimes ago we say that if I can have a circle here, so let's say this is O and this is A. I can draw the OA as a diameter. So this is the diameter. And then any point P can form a right triangle here. Can you see that? That's the problem we did earlier. Okay. And my suggestion is you use this. So basically, what you want is that I want to construct a circle such that OA with OA as a diameter. So the idea is that I want to construct a circle with OA as a diameter, right? If I can do that, then I'm done, right? So in other words, can I do this? So I'm going to connect this, right? And then all I want is that I want to make a circle in that way. Can I do this? If I can make such a circle, then I'm done. The intersection point. So you get one is the P, the other one is the P prime, and either one works. So how could I get such a circle? Well, if you want to get a circle, you need a midpoint. Well, how do I get a midpoint? So how? Well, just find a midpoint. Find the midpoint of OA. So I need such a midpoint, right? If I can find such a midpoint, let me call that B, then I'm done, right? I just go from the B here, I draw a circle with the center at B and the radius of OB. So that can give me a circle with OA as a diameter. And I get a two intersection point, P and P prime, and any one of them will be working. Does it make sense? Anyway, I'm running out of time because my next class we're starting 1 minute. So I'm going to stop here. And next time I'm going to do that again. So sorry, it's really, really fast for the last one. Okay. So I think that's all today. See you next time.
Bye. Thank you.
Bye, everyone.